everyone. Here this is our limit and continuity. So what is limit? If we take a function y is equal to fx, then for points x plus each, each tends to 0 plus, means that each is greater than 0 and tending to 0, then y will be changed and y will be y plus del equal to for x plus h now for points x minus h, h again tends to 0 plus and h greater than 0. This will be y minus del equal to x minus h. In graph, if we represent this, this is x-axis, this is y-axis. So if we take x any point, this is x plus h, this is x minus h, and if we take here y, in this way we will take a function y equal to fx, then this will be the fx at x plus h. This will be x plus h, and here this will be x minus h. So when we will find out, when we try to find out the limit of fx, this will be limit of fx h tends to 0 plus is equal to limit of fx h tends to 0 minus is equal to f a will take that for x is equal to a point, this is equal to fx is equal to fa, and for limiting value x tends to h plus x tends to a plus fx, this will be fa, and limit x tends to a minus fx is equal to fa. If these conditions are satisfied, then we say that limit x tends to, for this point x is equal to a plus fx is equal to limit x tends to a minus fx is equal to fa. Then we say that fx is continuous at x is equal to a. So not in this way actually, properly in this way. We will say that fx is continuous at x is equal to a. Now if we wish to know what is the differentiability of fx at the point a, to find out the differentiability, we will take let the change for this function y equal to fx, if we take x is changed to x tends to x plus h, where e plus minus h tends to 0. Then we will have del y is equal to x plus h minus fx, and del x is equal to x plus h minus x is equal to h. So the limiting value is the definition of the differentiation. Limit h tends to 0 del y by del x is equal to limit h tends to 0 f x plus h minus fx by h. Now This is the definition of differentiation. Definition of differentiation. So what is the condition of differentiability? If we will have limit h tends to 0 plus f x plus h minus fx by h is equal to limit h tends to 0 minus f x minus h minus fx by minus h. If this equality holds, then we call that the differentiation is continuous. Means this is denoted by in this way f prime x. So f prime x will say exists and continuous. Means the continuity holds. So we'll take some example. Like if we will take y equal to sine x, then what will be the differentiation of it by the definition of differentiation. So here we will take limit h tends to 0. So this is also denoted by dy by dx. Limit f x plus h minus fx by h. Limit h tends to 0. This can be written down fx plus h. This is actually equal to fx. So this will be sine x plus h minus sine x by h. If we use this function and replace x by x plus h, then we will get this, and this is given and h by the definition of differentiation. So we will have now sin c minus sin d formula. We know that sin c minus sin d 2 into cos c plus d by 2. This will be 2x plus h by 2 into sin c minus d by 2. So this will be h by 2 by h. So we can now rearrange this in this way. Limit h tends to 0 cos 2x plus h by 2 into limit h tends to 0 sin is by 2 by is by 2. So this is equal to 1, and here we will get, if we put h tends to 0, h equal to 0, we will get this is equal to cos x, and this is equal to 1, so we will get cos x. So differentiation of sin x, the first differentiation of sin x is equal to cos x. So this is an example of differentiation from the definition of differentiation. We will take another example. If we take y equal to e to the power x, exponent of x, then which is equal to fx. So here dy by dx is equal to limit x tends to 0 f x plus h minus fx by h, and limit x tends to 0 fx plus h will be e to the power x plus h minus e to the power x by h, limit h tends to 0. This can be broken down actually, e to the power x multiply e to the power h, e to the power x multiply e to the power h minus 1 minus e to the power x by h. So limit h tends to 0. If we take now common e to the power x, we will have under bracket e to the power h minus 1 by h. Now this is a constant form, it will not depend on this limiting value, so you can get out from this limiting value, you get e to the power x limit h tends to 0 e to the power h minus 1 by h. So this will be e to the power x, and this is, we know that this limiting value is equal to 1, this will be 1, so we will get e to the power x. This is another example of definition of differentiation. Thanks for watching. So both these functions are continuing, and that's why these can be differentiated. So both are continuous. Both functions are continuous. Thanks for watching.